increase their production line to be 300 units. We see the failure rate is increasing like that, and this is the total number of units and the number of tests for this company. Let's take a look graphically. What happened here is that once this company increased their production, the failure rate is increasing. So in other words, the quality of producing these motors has some problem in it. Okay, so with this information, the company can conclude that they need some improvement, that quality control has to be emphasized. Specifically, from this information, the mean time to failure of the motors, the products for the first 300 units can be captured. Okay, because we know the number of hours that are tested, okay, and the number of failed units for the motors. So the mean time to failure for the first 300 units is about 3,700 hours. What about the last 200 units? We see that the value mean time to failure is much less. That's about 360 hours. What does it mean? Mean time to failure, the average time that the motor fail. Okay. In general, we prefer a product, anything, to last as long as possible. So it means that we prefer higher mean time to failure. So now the information tells us that the more products, okay, in this production line, the worse the outcome. The failure rate are getting low and low. That's a bad sign. So quality control program has to be added. Okay, has to be involved in this product. Okay, in the process for this company. Let's see another example. It's about a system of VCR component that most of us have in our household, right? To watch a movie, right? To play video games, something like that. Let's say that information of a new VCR, okay, made by a company, it has the mean time to failure equal to 8,750 hours. That's the average time that a new VCR would fail. Okay, average. With this information, the probability of failure of a system can be captured. Okay, because there are some relationship between the mean time to failure and the probability of failure. That's the capital FT. Okay, the result here is 0.1176. So that's about over 10% chance of failure of a brand new VCR system. So that's something that this company would like to to improve, okay, that the probability of failure can be reduced. How? Let's see figure 1.2 in the text. You see like some kind of decreasing curve along this line. It is operating hours, and this axis is about the the fraction of fail. We see that the value is decreasing, so it means that the probability of failure or the number of the fail component is decreasing. So that's good. Okay, this could be obtained through reliability growth program. Okay, to improve the product reliability, and doing that, the warranty cost can be reduced. Let's see briefly about history of reliability engineering. Okay, because this field is pretty new to us, right? Most of us are not familiar with. So it's better to know a little bit of what happened before we are here, okay, in this field. It started for how long? Less than 100 years ago, right? This field, late 1930. We are going to learn later on about Weibull distribution. Okay, Weibull is the name of a person who analyzed the failure characteristic in material. Okay, and later on we use his name as the probability distribution function, the name. After that, in 1950, the U.S. Air Force would form up a group to analyze and improve equipment, okay, reliability in the general equipment. And then a couple years after that, Department of Defense, okay, this is also from the U.S., would form up another advisory group on reliability and electronic equipment, stand for AGREE. Okay, so we see that the initiation started from the U.S., okay, and specifically in a military organization, the government organization, okay, Air Force, Department of Defense. Okay, why are they related to, why do they have to worry or concern about reliability issue? The what? This one should be ad hoc group. So ad hoc is just like an unofficial group that they are just no. It's like, let's see, once we face a like unpredictable situation, let's say, like if something happened and is critical, Okay, and we